Hello student, today in this video we're going to discuss about class 10 chapter number 12 electricity. Now student, remember one thing before you proceed with your question answer and your numericals, and this chapter will get numericals. Okay, see, your concept need to be clear. If your concept is not clear, it will be difficult for you to understand, okay, the question answers and the numericals. And student, remember one thing, in any state board, in NBSC also, every year they ask one numericals from this particular chapter. Clear? It can be for 2 marks or 3 marks. So listen carefully, try to understand. Okay, clear? Now, as you know that the name of the chapter is electricity. What's electricity? Electricity is the study of charge. So electricity can be divided into two parts, that is static electricity and current electricity. See, static electricity is written here, charge will be in rest position, and current electricity means charge will be in motion. And student, one thing, this particular topic we're not going to discuss in class 10, this will get in class 12 science, okay, in physics. This one in class 10 we're going to discuss about this current electricity, charge in motion. Clear? Now before we proceed with with the topic, what is charge? You have to understand what is charge first. Okay, now it's written here, a charge is a physical entity which is defined by the excess or deficiency of electron on a body. Now, or in simple way we can say the charge is made of atoms. Okay, charge is made of what? Atoms. What's atoms? In class 9 you've learned, in lower class also you've learned. Atoms, what? Atoms are what? Made of what? Electron, proton and neutron. Clear? So see, look here, suppose this is an atom. Okay, what is the center of the atom? It called nucleus, and nucleus made of what? Your proton and neutron. Clear? Also remember one thing, proton are positive. Okay, neutrons are, they don't have charge, they are neutral. We said they are neutral. Now electrons will be present in the outermost shells here, example. Clear? So the electrons are negative. Always remember one thing, electrons are negative, proton are positive. So remember one thing, there are two types of charge, positive charge and negative charge. Positive charge are called proton, negative charge are called electron. Is it clear? So what's charge? In simple way you can say charge is nothing, is made up of what? Atoms. And atom, what is made up of? Proton, electron and neutron. Is it clear? Now, so remember one thing, there, as you know that there are two types of charge, positive and negative. Suppose what will happen if I brought two positive charge together or two negative charge together? What will happen? Remember one thing, if same kind of charge, if you brought together, right, they will repel. They will repel means they will move away from each other. Are you my point? Suppose if I brought opposite charge, suppose minus plus, plus minus, what will they will do? They will attract. They will what? Attract means they will come close to each other. Suppose my one hand is positive, example, and this your pen also positive. What they will do? They will repel, right? My hand is positive, this pen also positive, same charge, right? So they will repel. Repel means moving away. They will move away from each other. Agree my point? Suppose this pen is positive, my hand is negative charge. So what they will do? They will attract. They will come close to each other. They will attract each other. Clear? So what we've learned now, that there are two types of charge. One is positive charge. Positive charge are called proton, and negative charge are called electron. And what will happen if two same charge brought together? They will repel. They will move away from each other. And opposite charge, what they'll do? They will attract each other. Is it clear? So we have learned about charge. Charge is made up of atoms. Atom made up of proton, electron, and neutron. Proton are positive, neutrons are neutral, your electrons are negative. Is it clear? Now, what's written here? A body is said to be negative charge if it gain electron. A body is said to be positive charge if it lost electron. What it mean? See, suppose this pen. If this pen donate electron to this paper, example, if this pen donate electron to this paper, who's donating? The pen is donating, right? Anything which donate, they will have positive charge, and who's taking, they will have negative charge. Agree my point? Suppose this pen is donating electron to this paper, example, okay? So this pen will have positive charge and this paper will have negative charge. So what we've learned is that anything which donate, they will have positive charge, and anything which take, they will have negative, anything which donate, they will have positive charge, and anything which take electron will have negative charge. Is it clear? Okay. The last point is said that the SI unit of charge is coulomb. symbol is C, coulomb. I hope you know what's SI unit. Like the SI in class 9 you've learned what's the SI unit of speed, meter per second. What's the SI unit of acceleration, meter per second square. So similarly, charge also has one unit, that's called coulomb. Clear? And the symbol is C. Clear? Now next, see the smallest value. The smallest value of charge is, see, charge also have some value in it, right? So how many type of charge are there? There are two type of charge. One is negative, one is positive. Negative means electron, positive means proton. Now, see, can you see these two value? 1.6 10 power minus 19 coulomb, 1.6 10 power minus 19. These two values are same, right? But only minus and plus different, right? How? For electron we'll write minus, for proton we'll write plus. It's simple, right? So they have the same value, but only sign is different, right? For electron we'll write minus 1.6 10 to the power minus 19 coulomb. For proton we'll write plus 1.6 10 to the power minus 19 coulomb. Is it clear? Okay, next is about your electric current. What's electric current? Say it is defined as a rate of flow of charge, electric charge, through any cross section of a conductor in a unit time. Means what is said, electric current means flow of charge. Flow of charge in a conductor means the charge will move in a conductor from one point to another, okay, and they will lead to current. They will produce current, okay. Clear? In a given time. Simple. Suppose conductor, I hope you know what's conductor. Conductor means where you can say the current can flow easily, right? Like any kind of metal or conductor, right? So this conductor, obviously conductor, right? So conductor, obviously it will have atoms. Any conductor, anything have atoms, right? So it will have atoms, right? So atoms are made of what? Proton, electron. So obviously you need positive charge also there, negative charge also there, right? Right? Positive charge also there, negative charge. When the charge, when the particular charge, okay, either, see, actually in electricity we know that only electron are move, not the proton. We'll discuss afterward why only the electron move, not the proton, okay. Now for time being, listen, okay, just simple way. Suppose this is a conductor. When this charge, either positive or negative, move from one point to another, in a given time, that we say electric current. That we say what? Electric current. Is it clear? Now, so electric current symbol is what? I, okay. And what's the formula? Charge by time. Charge symbol is Q. It can be small letter Q or it can be capital letter Q. No problem. Clear? So I is equal to Q by T. So the SI unit of electric current is ampere. Okay, the SI unit of electric current is ampere. That's as like the SI unit of charge was coulomb, right? So for current is ampere. It is a scalar quantity. Scalar means, I hope you know, in class 9 you've learned about vector and scalar. Scalar means we just have direction. Now, what's 1 ampere? When 1 coulomb of charge flow through any cross section of a conductor in 1 second, then current flowing through it is said to be 1 ampere. What is that? Suppose, as you know that, suppose the charge, 1 coulomb of charge in this conductor flow in 1 second. In 1 second. What's the formula current, by the way? Current formula is charge by time. Current, I can write 1 ampere. Charge, I'll write 1 coulomb. Why 1 coulomb? Why coulomb? Coulomb is the unit of charge, and time, what's the unit of time? Second. This is called 1 ampere. What's 1 ampere? 1 ampere is nothing. When 1 ampere, in simple way you can say that 1 ampere means when 1 coulomb of charge flow in the conductor, 1 coulomb of charge flow in the conductor in 1 second. That is called 1 ampere. Is it clear? Now, so some smaller unit of current are given: milliampere 10 to minus 3, microampere 10 to minus 6 ampere. So this value sometime we need, okay, in numericals, okay. Now, suppose in a conductor current produced, right? How current produced? What's electric current? Electric current means movement of charge. Movement of what? Charge, right? When charge move, current produce. Now, you know, there's to measure anything, there's an instrument, right? we know, right? So like to measure our temperature, our body temperature, we have thermometer, right? Similarly, to measure the charge, or sorry, we can say the measure of current. If you want to measure the current, right, in a conductor, right, we use one device. The device is called ammeter. Ammeter is a device which is used to measure electric current. Clear? It is always connected in series in a circuit. What is series? What is series? Okay, we'll learn in the next videos. Okay, series connection, parallel connection. It's a low resistance device. What is resistance? This also we'll learn. Okay, I'll explain in one about this everything in one with the help of one figure. Okay, now this is called one circuit. See, this symbol is for bulb. This is called bulb. Okay, this is called this symbol of ammeter. What's ammeter? Ammeter is a device which is used to measure the current. This symbol is battery or cell. Clear? Always remember one thing: the current always flow from positive to negative. See, can you see this arrow? Positive coming and negative, right? Fine. Now see, and see, they are connected in one line, end to end, right? This bulb, right? Remember what is it called? This bulb. They are connected end to end or not? In one line. This is called series connection. This is called what? Series connection. We'll learn later after in detail about series connection and parallel connection. Now, as I said, always current always flow from positive terminal of a battery of a cell to where negative, means the current always flow from positive to negative. Is it clear? Now next is the direction of electric current is always taken as opposite to direction of flow of electron. To direction of flow of electron. Now student, as I with the it's better to explain with the help of a figure. Okay, fine. Now at first, okay, before we proceed, at first I want to tell you why, what are called conductor and what are called non-conductor. Okay, suppose, listen, okay, uh, this is a metal. This is what? Metal, right? Fine. And here is one, we say one non-metal. Fine. Always remember one thing: the atom of metal are a little bigger in size as compared to non-metal. Okay, what I said, the atom of metal are bigger in size as compared to non-metal. Suppose this one atom of metal, okay, not that much bigger, just example, and this non-metal, suppose this one. Fine. Now, as you know that the center is called what? Nucleus. Nucleus is what is your proton. The proton are what? Positive charge, and neutron is what? No charge, neutral, right? Now, as you know, they have what? Shells, right? Yeah, this will be a lot of shells. Now, here in this case, this for metal atom, this for non-metal, right? Always remember the atom of metal are a little bigger in size compared to non-metal. Okay, so electrons will be here, right, in the outermost shells. Clear? Here electrons will be there, here also. Nah. Okay, now what's the symbol of this nucleus? Nucleus is made of what? Proton, neutron. Proton are positive, so I can say this positive charge. Clear? Now can you see here the distance between this proton and electron is more or less compared to here? Obviously the distance between proton and electron are more here, right? But the distance between here electron and proton are less. What I said, student, remember? One minus sign, one positive sign, different charge, if they come close to each other, what will happen? They will attract each other, right? They will attract what? Each other. So attraction force will be strong where? Here or here? Again I repeat, the distance between the proton and the electrons are more here, right? But compared to here, because the distance less here. Remember one thing, distance less means the force will be more strong here. The attractive force means force, right? What attractive force? Positive and negative, they attract each other, right? So the attractive force will be strong here, but here not strong. So here free electron will be here, okay? Free electron will be here, but here no free electron, less free electron here, here more free electron. Why in metal free electrons are present? If someone asks you, say like that, the atom of metal are little bigger in size compared to non-metal. That is why the force between positive means your proton and negative means your electron is less, right? If force is less between them, electron will be loose, they will be free to move here and there, the electron will be free to move here and there. But here electrons are not free. That is why in non-metal charge does not flow, charge does not move, okay? Argument point. So non-metal white charge does not move because they don't have free electron. Why they don't have free electron? As the atoms are small, the force between positive and negative means proton and electrons are more, very strong force. So electrons are not free to move, it hold it, right? They hold each other, means the proton attract the electrons. But here in this case proton, the force between proton and electron is less. As the force is less, the electrons are free, the charge are free to move, the charge are what? Free to move. Clear? Argument point. The charge are free to move. That is why they are free to move, because the force between proton and electron is less, right? Okay. So how this for conductor, this for non-conductor, right? So in conductor, why the charge can move? Because the electrons are free, but here electrons are not free, and you have learned why electrons are free here and why electrons are not free here, right? Okay. Now your next is potential difference, or you can say voltage. Potential difference, or you can say what? Voltage. Now is defined as the work done per unit charge in a moving unit positive charge from one point to another. It is measured by an instrument called voltmeter, and SI unit is what? Volt. Now what's potential difference or voltage? See again with one. See, now it's very important topic. Listen carefully. If you understand this one, it will be very easy for you. Clear? Listen carefully. Okay. Suppose this one metal. Okay. So metal are, as we have learned now, just now, metal have what? Free electron, right? Now suppose suppose these are atoms, example. So atoms have what? Electron, right? Free electron. Example, this aluminum atom, it can be silver atom, anything, what kind of wire we're using or what kind of conductor we're using, right? Now one thing, what we've learned, in conductor electrons are free to move, right? But remember one thing, electron, they don't have direction. The electron, they keep on moving here and there randomly, but they don't have direction. But we want the electron to move in particular direction, clear? So to do that, we need to do something, right? For that, so this is a conductor, this conductor will connect with a battery, clear? This part is positive, or cell you can say. So this positive, so this will be positive, this side is negative, so this is negative, right? Now what will happen, see, this is your voltage. Now we're going to learn about voltage, this one, right? Your potential difference. Now volt. So as I said, electrons are what? Free to move here and there, but we don't want electrons to move here and there. We want the electron to move in particular direction. Now can you see, this side is positive, this is positive, this is negative or not? Clear? Now tell me, you know, these are atoms, right? These are positive, right? Now this is negative. So positive, negative, what they do? Positive charge, negative charge, what they do? Positive, negative, they attract each other, right? So see, this is negative, right? This is negative. So what they will do? They repel. Means this charge, what it will do? It will allow the, or it will allow the electron to move away from each other, because this is negative, this side is negative or not? These are negative, so they will not come close to each other. They will move away from each other, repel. But this what? Positive charge, right? These are what? Positive charge. These are what? Negative charge, right? So what will happen? Positive charge and negative charge, they will what? They will attract. Means the electrons will move in this direction. Why? The electrons will move from your from your right to left. Why? Because this side is positive, right? So these are electrons are negative. So positive, negative, what they will do? They will attract. They will attract each other, right? So the electrons will go this side. I got my point? But not this side. Why? This side is negative. Negative, negative, they never attract the repel, right? So now, because of this battery, the electrons are moving in one direction. So electrons are moving in one direction. Why the electrons are moving in one direction? Because of this battery. So this is called your potential difference or voltage, or we can say, what's potential difference or voltage? Is the work done by the battery. Is the work done by the battery to move the electrons. Clear? The work done by the battery to move down to move the electrons in a particular direction. You got my point, student? Again, I repeat. This is atom. So every atom have electron in it, as we already explained just now, right? So electrons will not move here and there by its own. In one direction. We want the electron to move in particular direction, right? Clear? To do so, we'll connect this conductor with a battery. Clear? This battery, what will do? Obviously, this side is positive, this side is negative. This side is positive because this side is positive or not? This side is negative, right? So positive and negative, what they will do? They will attract. So electrons will come this side, attract. Clear? This is negative, this is negative, they will repel. So electrons, this will push the electron this side, repel, right? So all the electrons will move in this direction, means right hand to left hand. So now the electrons are moving in one direction, right? The charge are going or not? So the charge are moving, right? So charge move means what it lead to? It produce current. It produce what? Current. What's the form of current we learn in the charge by time? Charge by time. So in this, with this figure, we can understand about charge, right? About current, because the charge are moving, so current produce. So clear? Fine. And about voltage also. What's the use of voltage? Actually, the voltage help the electron to move in particular direction. Is it clear? Now, see, it is measured by instrument. As you know, that what's the instrument used to measure current? Ammeter, we have learned, right? So same as the voltage, we'll use one device called voltmeter. We'll use what device called what? Voltmeter. Now what's the SI unit of potential? PD is potential difference, okay? Is volt. Is what? Volt. Is it clear? Now, so some larger unit of electric potential are 1 kilovolt is 10^3, 1 megavolt is equal to this kilovolt, megavolt, 10^6 volt. Clear? Now, see, next is Ohm's law. Okay, this law is given by George Simon Ohm in the year 1827. According to this law, the electric current flowing through a conductor is directly proportional to the potential difference applied across its end, providing the physical condition remains unchanged. Clear? So this is okay. We'll learn with the help of figure. See, as we know that now, when this voltage, I've already discussed this one, right? When this voltage or battery provide the power, the electron will move in one direction, right? So potential difference, V's potential difference is directly proportional to current. This symbol is called what? Directly proportional. Is it clear? This symbol is called what? Directly proportional. Now, as you know that if I want to remove this directly proportional, we have to write one constant. I write constant R, I. Your R is your called resistance. So about resistance we'll discuss in the next video. Okay, today we'll discuss about Ohm's law. What's Ohm's law? Ohm's law actually is a relation between voltage and current, right? So as you know that if there's a voltage, current will produce or not. How current will produce? When the charge will move. Always remember one thing, again I repeat, when the charge move, current produce. If the charge doesn't move, current will not produce. Clear? How the charge move? Because of your voltage. Clear? Because of your what? Voltage. Is it clear? Now, so as V directly proportional to I, voltage directly proportional to I. So R is called resistance of a conductor. So what's Ohm's law? Ohm's law is a relation between voltage and current. Voltage and current, and about resistance also. Clear? Now, see, I missed out about this particular topic. See, voltmeter. Okay, what's voltmeter? You know, right? Voltmeter is an instrument used to measure what? Potential difference. Now, voltmeter is always connected in parallel, okay, in the circuit, and it's a high resistance device. So this is the connection. See, one down on the right. So this is a symbol of voltmeter. What's voltmeter? Is used to measure potential difference. Now this is a bulb, you know, we have already learned, right? So this type of connection we say parallel connection. We say what? Parallel. Say about series connection and parallel connection we'll discuss in the next video. Okay, now what's 1 volt? When 1 joule of work is done to move a charge of 1 coulomb from one point to another, is called 1 volt. Simple. Suppose, what's 1 volt? When 1 joule of charge, so obviously what's the function of voltage? To move the charge. When 1 joule of charge, right, moved. Clear? When 1 joule of, so when work done, so the work done to move the charge, right, of 1 coulomb. Clear? So what's 1 volt? 1 volt nothing, is the work done in moving the charge of 1 coulomb. Clear? Can you see? What's 1 volt? Again, see, again, check once. When 1 joule of work is done to move a charge of 1 coulomb from one point to another, is called 1 volt. Means when 1 joule of work, see, if anything, if you want to move anything from one place to another, we need to do the work, right? I hope you know what's work. What's the form of work in class 9? Force into displacement. Force into what? Displacement. Now when 1 joule of work need to be done to move 1 joule, so 1 coulomb of charge, is called 1 volt. Again I repeat, when 1 joule of work need to be done to move 1 coulomb of charge, is called 1 volt. Is it clear? Simple, right? Now again we are back to the Ohm's law. Okay, now what's the Ohm's law? Ohm's law is the relation between what? Your potential difference and your current, right? And if we remove this directly proportional sign into equal, we write one constant. This is called resistance. Okay, this is called what? Resistance. Clear? Now see, this is very important, this part. If voltage is increased, current will increase. That is, more charge will flow. What it mean? Suppose if I increase this voltage power, you know, battery have different powers, right? We can get 6 volt, 5 volt, 1.5 volt, right? If we increase the power of this battery, right, what will happen? More charge will move. More charge will move. Remember one thing, more charge means more current. Are you getting my point? So what we have learned, that if voltage is increased, current will increase. Why? More charge will flow, right? See, again I repeat, if I increase this power of this battery, right, what will happen? It gives more power to it, so means more charge will move. More charge means more current. So always remember one thing, if you increase the voltage, current will increase. Clear? Similarly, if voltage decrease, then current will decrease. Similarly, if I decrease this one value, right, obviously less charge will move. Less charge means current will be less. Are you getting my point? Fine. So now using this formula we can write like it also. I is equal to, right, V by R, right? Suppose this is a form of current again. So one form of current was charge by time, in terms of charge, right? In terms of resistance, we can write this formula, right? V by R, V by R. So this kind of formula is very useful in numericals. Okay, fine. Is it clear? Now what's written here? The last C. If resistance double, then current will get half. Half means what? Half means less, half of the original value. Half means what? Half of its original value. If resistance half, then current will get double. What it means? Suppose you know this formula, right? Suppose if I increase the resistance, what will happen? Current will decrease. Okay, remember one thing, if we increase the resistance of a particular thing, current will decrease. Okay, so now might be wondering what is resistance, right? Student, in the next video we're going to discuss about the resistance. I hope you understood whatever we explained today. Again, I repeat, what is charge? Charge is nothing, is made up of atom made up of what? Proton and electron, neutron. So remember one thing, there are two types of charge. One is proton, one is electron. Proton are positive, electrons are negative. Clear? So if same charge brought together, plus plus, what will happen? They will repel, they will move away from each other. And if we brought opposite charge, minus plus, what will happen? They will attract toward each other. Is it clear? Now what is current? Again, what's current? Electric current. Electric current means movement of charge. If the charge move, as we have learned in this figure how the charge move, right? As the charge move from one point to another, current will produce. Clear? Now that's called electric current. And ammeter is a device used to measure electric current, right? Now electron, the charge can move by its own. No, we want the electron to move in one particular direction, right? That's why we use one term, potential difference or voltage. If we can say, if in example, if they ask name one particular thing which supply the potential difference or voltage, we can say battery or cell. So if you apply voltage or any battery, right, so electron will move in particular direction and current will generate, right? Fine. And always remember one thing, the direction of current and electrons are always opposite to each other. Clear? Suppose the electrons are moving this side, right, the current will be this side. Clear? I got my point. So direction of electron and direction of current are always opposite to each other. So voltmeter is a device which is used to measure what? Potential difference. Now the relation between potential difference and current is called Ohm's law. Ohm's law is the relation between potential difference and current. Is it clear? Now so we have learned now in one I explained to you, right, why some say some are good some are say metal and some are say non-metal, right? Why in metal or in conductor electrons are present, free electrons are present, and in non-metal free electrons are not present. I already explained to you, right? Yes or no? Why? Tell me. I have already explained to you. See, in any metal, okay, the size of an atom is little bigger than the non-metal. The size of atom is little bigger of the what I'll say, the size of metal. The size of atom for metal are little bigger as compared to non-metal. Clear? So it means that in metal electrons are free, right? And in non-metal electrons are not free. Clear? That's why metals conduct current, allow the charge to move. Clear? Fine. So student, for today this much for this video. In the next video we'll explain about resistance. Okay, if you have a doubt please ask. Okay, thank you.